Good morning everyone. I am Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to discuss about some of the AC bridges we have. As we know that bridges are mainly used to measure unknown parameter like inductance, resistance and capacitance. Today we are going to discuss about two types of bridges. One is resonance bridge and another one is Wagner's earth connection or Wagner's ground connection. And coming to the resonance bridge, with this we can measure unknown frequency. At the same time, we can also find out the unknown resistance, inductance and capacitance. Similar to the normal AC bridges, this resonance bridge also consists of 4 arms. The 4 arms of the bridge, these are the 4 arms, first arm, second, third and fourth. These 4 arms make a bridge network. In this, the 2 opposite arms of the bridge are connected to an AC voltage and the remaining 2 arms of the bridge is connected to a resonance or galvanometer. In this, initially the bridge is present in balanced condition. As we know that whenever the bridge is present in the balanced condition, with the help of balanced bridge we can measure unknown parameter. So to find out balanced bridge condition and to measure unknown parameters, first of all we need to calculate impedance across each arm. And the balanced bridge condition is Z1 into Z4 equal to Z2 into Z3. From this unknown parameter is if it is Z4, then Z4 equal to Z2 Z3 by Z1. This is the balanced bridge condition if it is an AC bridge. So that to measure unknown parameter we need to calculate Z1, Z2, Z3 and Z4 across each arm. Now Z1 is nothing but RB. We have only one resistance across the first arm. Similarly Z2 equal to RC. We have only one arm across the second, only one resistance across second arm. Consider to the third arm. The third arm also consists of only one resistance, that is ZA. Now fourth arm. Across the fourth arm there is a series combination of inductance, capacitance and resistance. So that the Z4 can be represented as Z4 equal to RD plus 1 by J omega CD plus J omega LD. This is Z4. After simplifying this Z4 equal to RD plus 1 by J omega CD plus J omega LD. By taking LCM here, we can simplify this equation. J omega CD is the LCM. Then we have J omega RD CD plus 1 minus omega square LD into CD. This is Z4. Now we have 4 impedances across 4 arms, Z1, Z2, Z3 and Z4. Now substitute these 4 impedances in balanced bridge condition, that is Z1 into Z4 equal to Z2 into Z3. So that Z4 equal to Z2 Z3 by Z1. Z4 means what? 1 plus J omega RD CD minus omega square LD into CD by J omega CD, which is equal to Z2. As we know that Z2 equal to RC and Z3 equal to RA. Similarly, Z1 is RB. Now, by cross multiplying this equation, we can simplify the expression, that is 1 plus j omega RD into CD minus omega square CD into LD into RB, which is equal to j omega CD, RA and RC. Now, again simplifying this equation, RB plus j omega RD CD into RB minus omega square CD LD into RB equal to j omega CD RA into RC. Now, equate real terms on both sides and equate imaginary terms. Equate real and imaginary terms on both sides. By equating real terms on both sides, real terms means we have three real terms, RB minus omega square CD LD into RB, and on right hand side the real term becomes 0. So, if we equate the real terms on both sides, then RB minus omega square CD LD into RB equal to 0. Now, by taking RB as common, 1 minus omega square LD into CD equal to 0. This becomes 1 minus omega square LD into CD is equal to 0. So, omega square LD into CD equal to 1. Now, we can re-represent this one as omega square equal to 1 by LD into CD. As we know that omega equal to angular frequency, the relation between this angular frequency and a normal frequency is omega equal to 2 pi f. Now we can replace this omega with 2 pi f, then omega square becomes 2 pi f whole square equal to 1 by LD CD. From this, f square equal to 1 by 2 pi whole square LD into CD. But we need resonant frequency f. Now, resonant frequency f equal to 1 by 2 pi root LD into CD. Finally, we obtain the resonant frequency as 1 by 2 pi root LD into CD. This resonant frequency is obtained only when we are equating real terms on both sides. Similarly, if we equate imaginary terms on both sides, what are the imaginary terms? We have two imaginary terms, j omega CD RD into RB equal to j omega CD RA RC. Now, when we equate imaginary terms on both sides, j omega RD CD, j omega RD CD into RB equal to j omega CD RA RC. This is obtained only when we are equating imaginary terms on both sides. If we equate imaginary terms on both sides, j omega get cancelled, CD will be cancelled. Finally, RD into RB equal to RA RC. Now, we need to calculate this RD. So, RD equal to RA into RC by RB. In this way, we can measure unknown resistance. By this, with the help of resonance bridge, we can measure unknown frequency. At the same time, we can also calculate unknown resistance. Resonance bridge, it is an AC bridge. With this bridge, we can measure unknown frequency. So, to measure this unknown frequency by using resonance bridge, we need to find out whether the bridge is present in balanced condition or not. If the bridge is present in the balanced condition is nothing but Z1 into Z4 equal to Z2 Z3, which represents that the product of two opposite arms must be equal. Whenever the product of two opposite arms are equal, then the bridge is said to be in balanced condition. If the bridge is present in the balanced condition, we can measure unknown parameter. Now, to find out these unknown parameters, we need to calculate impedance across each arm. We have 4 arms in this resonance bridge. The first arm having resistance, second and third arms also having only resistance. Whereas fourth arm consists of series combination of inductance, resistance and capacitance. Now, across each arm, measure impedances. So, Z1 equal to RB and Z2 equal to RC, Z3 equal to RA, whereas Z4 is series combination of resistance, capacitance and inductance. So that we can represent Z4 as RD plus 1 by J omega CD plus J omega LD. Now simplify the Z4 as by taking LCM as J omega CD, we get the expression as Z4 equal to 1 plus J omega RD CD minus omega square LD CD by J omega CD. Now substitute all 4 impedances in balanced bridge condition. Then we have Z4 equal to Z2 Z3 by Z1. That is, substitute all 4 impedances and then cross multiply these two terms. Then we have the final equation. In this equation, equate real terms on both sides and equate imaginary terms on both sides. When we equate real terms on both sides, then we have RB minus omega square CDLD into RB equal to 0. By simplifying this expression, we get the resonant frequency F as 1 by 2 pi root LD into CD. Similarly, when we equate imaginary terms on both sides, then we have J omega CD RD into RB equal to J omega CD RA RC. By simplifying this one, we get the unknown resistance RD equal to RA into RC by RB. This is unknown resistance that can be measured with the help of resonance bridge. Finally, we can say that by using this resonance bridge, we can measure unknown frequency which is equal to 1 by 2 pi root LD into CD and unknown resistance RD equal to RA RC by RP. This is resonance bridge. And next one is Wagner's ground connection or Wagner's earth connection. What is the need of this Wagner's earth or ground connection? Why we are studying about this Wagner's earth or ground connection? As we have already discussed that if it is an AC or a DC bridge, the bridge always consists of 4 arms. Across each arm there exists either resistance, inductance and capacitance. Along with these resistances and inductances and capacitances, there exist some stray capacitances. Due to this stray capacitance present in the circuit, we may get so many losses. So that always we need to calculate the stray capacitances that are internally existed across each arm, so that the losses due to those stray capacitances can be removed and finally we obtain the output without any losses. So that to remove these stray capacitances and to get lossless output, we are using this Wagner's earth or ground connection. In this Wagner's earth or ground connection, we have 4 arms of a bridge. The first arm consists of resistance. This is a variable resistance. And second arm consists of another resistance R2. And third arm is the series combination of resistance and capacitance. Fourth arm also consists of series combination of resistance and capacitance. In this, if the bridge is present in this, the 2 opposite arms of the bridge are connected to an AC voltage and the remaining 2 opposite arms of the bridge is connected to an headphone. Along with this, the stray capacitance present across these headphones are grounded. Now, along with this, if you observe the bridge circuit, the bridge consists of one more resistance and capacitance, and the junction point of this resistance and capacitance is internally connected to a switch point 2. So, this is the Wagner's earth and ground connection. The main purpose of this Wagner's earth or ground connection is to remove the effects or losses due to stray capacitances that are existed internally across each arm. Now, coming to the operation of the circuit, initially the bridge is connected across with these 4 arms only. Now, if we connect the bridge, when the bridge is present in the balanced condition, then we can measure these 2 unknown parameters. But if the bridge is present in unbalanced condition, then there is a hum or noise that may be present across these headphones. So, initially the bridge is connected normally, nothing but we have a switch S across this headphone. If the switch S is connected to point 1, first condition or first case, in this first case, the bridge is connected as usual, and then by varying the resistance R1, this is a variable resistance, by varying the bridge resistance R1, we make the bridge in balanced condition. Even though if we vary the resistance R1, sometimes the bridge may not be balanced. In that case, this headphones produces some hum or noise, so that we can conclude that the bridge is present in unbalanced condition. So, to rebalance the bridge, again, the switch S is connected to point 2 instead of point 1. We are removing the connection across the first point, and the bridge now it is connected to point 2. This point 2 is internally connected to a unknown resistance, another resistance RW and CW. Now, if we connect the switch S to a point 2, then by varying the resistance RW, we have to make the bridge in balanced condition. Even though if we connect the resistance RW, the bridge is present in unbalanced condition. In this case, again by varying the resistance, we have to make the bridge in balanced condition. If the bridge is in the unbalanced condition, again it produces hum or noise. So, if we connect the switch S to point 1 or point 2, by making the changes or by varying the resistance across this R1 or by varying the resistance RW, we have to make the bridge in balanced condition. And after doing this connection from point 1 and point 2 to the particular bridge across the point S, after a long time, the hum becomes 0 and now the hum becomes 0 and the bridge becomes balanced. Whenever the bridge is present in the balanced condition, we can find out the unknown parameter. That unknown parameter may be Rx or Cx. So the main purpose of this Wagner's earth or ground connection is to remove the stray capacitances or to avoid the stray capacitances, mainly to avoid the losses produced by the stray capacitances. We are grounding the stray capacitance. Along this, additionally, we are attaching one more arm that consists of RW and CW. These two are connected to a point 2 from the junction point of RW and CW. This is called as Wagner's earth or ground connection. So, by using this, we can remove the losses due to stray capacitances. And another thing is resonance bridge. In this bridge also, we can measure unknown frequency and unknown resistance by using balanced condition. So, in this Wagner's earth or ground connection also, after getting the bridge in the balanced condition by using same formula Z1 into Z4 equal to Z2 Z3, from this Z4 equal to Z2 Z3 by Z1. Using this balanced bridge condition, after getting the bridge balanced, we have to find out the unknown parameter. But finally, the Wagner's earth or ground connection is mainly used to avoid the losses and to get lossless output across the output section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.